today we are going to see which are the compounds that are giving flavor to our food. So we'll see one by one. The first category of compounds is terpenoids. So these terpenoids, they are also known as isoprenoids, terpenes, etc. Okay, so based on the structure, that is, this is known as an isoprene unit. So this is the major structure part of this terpenoids. So based on how many isoprene units are there, we can classify terpenoids into different categories like terpenes, triterpenes, tetraterpenes, sesquiterpenes. These sesquiterpenes are basically terpenes which is having 15 carbon atoms, and usually they will be of the formula C15H24, and they will be having three isoprene units. Okay, so that are sesquiterpenes. So terpenoids, they are also known as isoprenoids and terpenes, and these compounds are majorly responsible for the flavor of our lemon and other citrus fruits. So which is a major compound which is giving the flavor to citrus fruits, that is terpenoids. And which is a major structural unit of this terpenoids, it is known as isoprene. So, and based on this isoprene, we can classify it into mono, di, tri, tetra, and sesquiterpenes. In sesquiterpenes, what is the specialty? It will be having 15 carbon atoms and 3 isoprene units. So we have discussed like in majority of our foods like lemons and other citric fruits, the flavoring component is this terpenes, right? So these terpenes, they are highly sensible to oxygen, air, etc. That is, when these components get exposed to oxygen and air, it will undergo some changes. Okay, and due to that changes, there will be some change in flavor we can observe, right? So when in our home, when we were preparing this lemon juice, when it is fresh, it will be having a good flavor. After some time, what will happen? The flavor will reduce. After some more time, what will happen? Even that sourness, it will turn to some bitter kind of thing, right? So that is because of the reaction of these terpenoids with the atmospheric oxygen or air. Okay, so that's why the citrus juices which are prepared at low temperature or in vacuum conditions will be having superior flavor. Okay, this you might have noticed. So similarly to the terpenes, there will be also a loss of vitamin C also. So that's why every time we'll tell like we have to prepare lemon juice in cold water. Okay, so that we can save all these components. Okay, is it clear?
Yes,
Is
ma'am.
it clear? Okay, now we'll see some of the examples of our...
Ma'am, can you explain the last point once again?
Last point which I was telling is like, we told like this terpenoids, they are sensitive to oxygen, right? So that is, when we are preparing some lemon juice or something, and normal atmospheric conditions, what will happen? This terpenoids, it get oxidized and we'll be losing this compound. So there will be a change of taste, right? You know, right? When we are tasting a fresh lemon juice, what will be its flavor? It will be having some sour flavor, no? So, and when we are preparing lemon juice and if we are keeping it for some time, what will happen? There will be a change of taste. Like after some time, the sourness also will change to some bitterish kind of taste, right? So that is because of this oxidation of terpenoids. So that what we can do in order to prevent this oxidation, we can prepare lemon juice using cold water, so that for some more time we can save this taste. So the techniques which we can use is like low temperature storage, or if we can go for vacuum storage. So if we are going for these two conditions, what will happen? We can preserve this terpenoids. Thereby we can preserve the flavor of our component. Okay, got it? Is it clear now?
Yes, ma'am.
Okay. So we'll see some of the examples. Like we have many classification of terpenoids, like monoterpenoids are there, hemiterpenoids are there, sesquiterpenoids are there, sesquiterpenoids are there, lactones, tetraterpenoids, triterpenoids, diterpenoids, so many things are there. So we'll see some of the important things like linalool. This is important. And menthol is also the terpenol, thymol, eucalyptol, then gingerbread, which is present in ginger, then cholesterol, lycopene, zeaxanthin. So these are some of the important terpenoids. Just you have to remember this name. So which are some of the important terpenoids? Linalool, menthol, thymol, eucalyptol, gingerbread, cholesterol, and zeaxanthin. Just these names you just remember. That's it. This is some other important terpenoids we'll see. So the first one is limonene. So limonene is a compound. It's basically a monoterpene. And this is having a lemon-like odor. And this is present in most of our citrus oils. Okay. So the compound which is present in our citrus oil is limonene, and which gives this lemon-like odor. And another compound which is present in our lemons is neral and geraniol. This is also present in lemon. Okay. This compound is also responsible for this odor of lemon. Another one is nootkatone, and this compound is responsible for the flavor of grape. Okay, this is an example for our sesquiterpene. Okay, so this limonene, neral, and geraniol. These four components are present in lemon, and this nootkatone is present in what? Grapes. Okay. So then, like as we discussed in lemons, similarly in orange and grapes also, what will happen? The same terpenoids are present. So then what will happen? It will react with oxygen. So some conversion will take place. So what is happening is like this limonene, a compound called limonene monolactone will be there in, and this compound is present in orange and grapes. So when reacts with oxygen, what will happen? It will convert into limonene. So this conversion is responsible for that bitterness of orange and grape. So that is, we are keeping this juices for some long time. What will happen? A slight bitterish taste will develop. And what is the reason for this? It is due to the conversion of this limonene monolactone into limonene. So this conversion will happen in the presence of oxygen. Okay. So here also we can do, like we can go for low temperature vacuum, or else we can expose our fruits to some amount of ethylene. So this also removes this precursor. So this is the precursor for the bitter formation, right? So when we are removing this, what will happen? This bitterness won't develop, right? So that is the conversion of this compound into limonene will not take place. Okay. So for removing that, we can add ethylene. Okay. So this is about oranges and grapes. So now we'll move on to our next compound, which are known as flavonoids. So flavonoids you all may be knowing. So flavonoids are nothing but phenolic compounds. So these are natural substances with a variable phenolic structures. Okay. So as in our common fruits like oranges and lemons, so these are the pigments which are present. So this hesperidin is present in oranges and lemons. And this naringin is a compound which is present in grapefruits. So these are examples for flavonoids. And if you are taking the taste of this hesperidin, This hesperidin is basically tasteless. It doesn't have any taste. But this naringin is having a bitter taste. So that is when we are, if in your house, if you are having some grapevines, and the grape, when it is in that small stage, when you are tasting it, what will happen? It will be bitter in color, bitter in taste. So as it ripens, the conversion of naringin will take place. That's why we are after ripening, we'll be having the sweet taste. Okay. So this naringin, as the fruit matures, this naringin will convert into a chalcone compound. So then this bitterness will change into sweet taste. Okay. And both this hesperidin and naringin, they're basically glycosides. That is, they'll be having a sugar unit. So that also we have to see. So what we have discussed, flavonoids are phenolic compounds, and some of the commonly occurring flavonoids are hesperidin and naringin. And where hesperidin is present in oranges and lemons, and naringin is present in grapefruits. And we have also discussed like hesperidin is tasteless and it is a glycoside, but naringin is bitter in taste. So when the fruit ripens, this naringin will get converted into a chalcone compound, which makes the fruit sweeter one. Okay. So in all these flavoring compounds, you just have to remember like which is the compound and where it is present and what is the taste. So these are the important things. So generally, flavonoids are classified into many categories. So flavonoids can be of anthocyanins, chalcone compounds, flavanols, flavones, flavonols, isoflavonoids. So this is the major classification of flavonoid components. So which are the major components which are coming under the flavonoids? Anthocyanin, chalcones, flavanols, flavones, flavonols, and isoflavonoids. And these are the examples for compounds which are coming under anthocyanin classes. That includes your cyanidin, malvidin, delphinidin, purinidin. So these are the compounds under this anthocyanin. And some of the chalcone compounds includes fluoretin, arbutin, fluoridicin, chalconarengin. And some examples for flavonoids includes hesperidin, naringin, naringenin, erioditiol, hesperidin, and some other examples for flavonoids, isoflavonoids are given. And this important ones includes your quercetin, myricetin, rutin, camphenol. So these are some of the important ones. So in these compounds, so you just have to remember like these are all examples for flavonoid compounds. So these are some of the important ones. That is arbutin, naringin, hesperidin, quercetin, myricetin, rutin, and camphenol. So these are some of the examples for flavonoids. Another one important flavoring compounds are our sulfur compounds. So these are the compounds which are responsible for the flavor of our onion. Okay. So this contributes a mixture of flavor, right? The onion smells are a combination of some pleasant and unpleasant flavor, right? Some people will like and some people don't like. Okay. So these sulfur compounds, so when we are taking an onion in its raw form, that is before peeling, you won't be sensing any smell, right? Okay. After cutting it only, we can feel that smell, right? So that is, these compounds, they are present inside the tissue. Okay. So these compounds are inside the tissue. So when the tissue is as such, the compound will also be included. So when we are taking an onion and when we are cutting it, what will happen? The tissue will get open, right? So this compound also will expose to oxygen. So that when we are cutting only, the compound will get disrupted and we will feel the smell. Okay. So we told like these are the main compounds which are responsible for the flavor of onion. That is, if you're taking allium, the flavor precursor is known as the cysteine sulfoxide and its derivatives. So these compounds give the particular flavor to allium. Okay. And about the garlic, the order of garlic is due to the compound allicin. This is also important. Okay. In some previous years, they have given this for match the following. Okay. So the flavor compound which is responsible for that characteristic flavor of garlic is allicin. So when this allicin is formed from alline. So this is the precursor compound. Alline S2 prophenyl cysteine sulfur dioxide. This compound, by the action of this enzyme allinase, will get what? Will get allicin. This is how allicin is produced by the action of alline S2 prophenyl cysteine sulfoxide. It will get converted into allicin with the action of enzyme allinase. Okay. So these are some of the compounds, and this is very, very important. We have to learn this because many times these flavoring compounds has been asked in the exam in the form of match the following. Most probably, they'll give the name of compound and they'll be giving the food material. They'll tell to match it. Okay, so this is very, very important. We have to learn this. So the flavoring compound which is present in tomato and raspberries is cis-3-hexane 1-ol. The flavoring compound which is present in mushroom is 1-octene 3-ol. And geosmin, it is a flavoring compound which is present in beetroot's dry beans. And the compound in cheese is phenol. P-vinyl guaiacol is a flavoring compound which is present in clove oil. This eugenol is also present in clove oil. Thymol is present in thyme. In butter, it is acetaldehyde. Hexenol is present in apple. Acetic acid, you all know it is in vinegar. And in cranberries, the flavoring compound is 2-methyl butyric acid. And if you are taking mutton, there are so many branched chain and unsaturated fatty acids are there which are responsible for its flavor. Okay, so this is very, very important. We have to learn it. Okay, till this, is it clear?
Yes, ma'am.
Yeah, okay. Now we will see some of the ester compounds which are giving some characteristic smell. Okay, the smell of banana is due to isoamyl acetate. And the smell of pineapple is due to ethyl butyrate. In peaches, it is benzyl acetate. In pears, it is N-propyl acetate. And the smell of flowers, mostly it is because of benzyl butyrate. And the apples, it is methyl butyrate. And the smell of rum is due to isobutyl propionate. In oranges, it is octyl acetate. And in grapes, it is methyl anthranilate. So these are some of the compounds which are responsible for the smell of fruits. Okay, this is also important. You have to see. So now we'll move on to anti-nutrients in food. So what do you mean by anti-nutrients? Like normally, we'll be taking our macro and micronutrients, right? So in our food, we'll be having protein will be there, carbohydrate will be there, fat will be there, minerals will be there, and vitamins will be there. So normally we'll ingest our food and it has to digest, right? So if there is some substance which inhibits the maximum utilization of all these compounds. Like it can be in the form of like some compounds will reduce the absorption of this compounds, or else some compounds will bind with that nutrients and form some other complex. Like that, the components which reduces the maximum utilization of all these nutrients can be referred to as anti-nutrients. So what are anti-nutrients? Anti-nutrients can be defined as chemical substances which reduces the maximum utilization of nutrients, especially our proteins, vitamins and minerals. Okay, and thus what will happen, we'll not be getting adequate amount of nutrients, so that we'll be having the nutritional deficiency or some associated diseases we'll be having. So such kind of compounds are known as anti-nutrients. Now we'll see which are the common types of anti-nutrients. And the first important one is phytates. These phytates, they will reduce, they'll go and bind with this calcium and iron. And what will happen? Thus the absorption of this calcium and iron will reduce. Okay. And that is the effect of phytates on our body. And the second one is oxalate. This oxalate also reduce the absorption of calcium. So thus excess amount of calcium will be excreted through our urine, and thus there are chances for this kidney stone also. So cyanide compounds that we all know, they are all respiratory inhibitors. They'll inhibit the respiration mechanism and cause lethal effects. And then another anti-nutrient is lecithins or hemagglutinin, which are commonly present in our red kidney beans. What will happen? They will prevent the absorption of digested products in the intestine. Okay, so they will inhibit the absorption of the compounds from the intestine. Then we'll be having protease inhibitors. So what these protease inhibitors do? They will reduce the digestion of protein. And then some phenolic compounds like tannins are there. So they also reduces the bioavailability of minerals. That is, they'll go and bind with these minerals and reduces their absorption. Also, they can also have some effects like protein indigestion. So those effects are also there for this phenolic compounds. So which are the functions of phytates? Phytates reduce the absorption of calcium and iron. What does oxalates do? They reduce the absorption of calcium. Cyanide is respiratory inhibitor. Then protease, it reduces the absorption of protein. Then what does this phenolic compounds like tannin do? They also reduce the bioavailability of minerals. So we'll see one by one. And the first one is trypsin inhibitors. So these trypsin inhibitors, they are also a kind of protein inhibitors. That is, they interferes with protein digestion. So the major sources are our legumes. It's rich in soybean, peas like PGNP, the red bean. So these are the compounds which are having high amount of trypsin. So we know, like, when we are consuming all these things, we'll be getting this anti-nutrients, right? So for preventing this, what we are doing, we can do cooking, right? So which are the preventive measures? We can go for autoclaving or cooking we can do. Then we can soak it, or we can go for germination. So these are the treatments which we are commonly using to reduce the amount of these anti-nutrients in our food. So what are trypsin inhibitors? They are anti-nutrient components which interferes with the protein digestibility. Okay, and they are rich in legumes and pulses. And what we can do to reduce their availability? Either we can cook it, or we can soak it, or we can germinate it. So these are the commonly used techniques. And another very important compounds are vicin and covicin. So this vicin and covicin, they are present in fava beans.
To watch the full video, purchase our course Space for Gate 2.0 only on www.acescapes.in or the AceScape mobile application.